Worksheet 4.3. So for question 1, we want to find the general solution for sine of x is equal to a half. So first of all, we're going to start by drawing up our triangles here. Our 2, 2, 2 triangle here, so pi on 3, and our angle up here, pi on 6. We've got 1 cut in half, and here 4 minus 1 is root 3. We'll draw our other triangle as well here. We've got pi on 4, 1, 1, and root 2 here. So for sine of x to equal a half, here our opposite over hypotenuse, we're looking here at our pi on 6 here. So here we want alpha is equal to our minus 1 a half. So we're looking here pi on 6, and if we're thinking about our sine and it's positive, here it's going to be in quadrants 1 and 2 here. So we're going to have pi on 6 and pi minus pi on 6, so 5 pi on 6 here. So here we can enter these into our actual formula here. We've got x is equal to n pi plus minus 1 to the power of n of alpha, so here pi on 6, or n pi plus minus 1 to the power of n, 5 pi on 6 here. And to make it neater, we're going to take our fraction out the front. Here 1 over 6, so pi is 6 pi on 6, so 6 n pi plus minus 1 to the power of n pi. Or here, same again, we take our fraction out the front. Here 6n pi plus minus 1 to the power of n of 5 pi here. So for question 2, we've got cosine of x plus 1 on root 2 is equal to 0. So our first step is going to be moving it over to the other side here. So cosine of x is equal to minus 1 on root 2 here. So we think about this, we've got negative, we're going to be here in quadrants 2 or 3 here. And here we've got 1 on root 2 for our cosine. Here is going to be our pi on 4 ratio. So alpha is going to be, in quadrants 2, pi minus pi on 4 and pi plus pi on 4 here. So we're going to be here 3 pi on 4 and 5 pi on 4. So now using our formula, x is equal to 2n pi plus or minus alpha. So in our first case, we're going to have 2n pi plus or minus 3 pi on 4. In our second case, 2n pi plus or minus 5 pi on 4 here. So we're going to again take our fraction out the front here. So we're going to have 1 quarter out the front here. So 2 pi becomes 8 pi on 4 plus or minus 3 pi. And here again a quarter out the front, 8n pi plus or minus 5 pi. So now looking at question 3. 3 is a bit of a funny one, and we're not going to solve it the whole way in this case here. So we've got 5 tan of x is equal to 1. Tan of x is equal to 1 on 5 here. So this doesn't fit into any of our actual units here. So what we're going to do is just keep it like this here. So what we're going to say here, so alpha is equal to inverse tan of 1 on 5, and we'll just keep it like that. X is equal to n pi plus our inverse tan of 1 on 5. So for question 4, we have, well, sine squared x is equal to a half. So our sine of x is equal to square root of a half, or 1 on root 2. So 1 on root 2 here matches in with our triangle here, so pi on 4. And here we go back to this one here, we're sine of x and we're positive, so we're going to be here in quadrants 1 and 2. So we're in quadrants 1 and 2, and it's pi on 4 here. So what we're going to have, our alpha is going to be equal to pi on 4 for quadrant 1, and pi minus pi on 4 is 3 pi on 4 for quadrant 2. So we have x is equal to n pi plus minus 1 to the power of n pi on 4, and here n pi plus minus 1 to the power of n, 3 pi on 4. Again, we take our fractions out the front. So a quarter out the front. Here be 4n pi plus minus 1 to the power of n pi. And our other one here, a quarter out the front, 4n pi plus minus 1 to the power of n, 3 pi. So looking now at question 5. Here we're going to find the general solution of sine of 2x is equal to 1 on root 2. So we could be looking at our double angle formulas here, or we could just be thinking it through and finding what our values for 2x are and dividing by 2 at the end. So here, we've got here 1 on root 2, so 1 on root 2 for our sine is our pi on 4 value here. So we come back here. So here we have our alpha is equal to, and we're positive, so we're going to be in quadrants 1 and 2. So pi on 4 and pi minus pi on 4 is 3 pi on 4 here. So we say, well, 2x, instead of our x, we can write here our 2x into our formula. N pi plus minus 1 to the power of n alpha, so we've got pi on 4, and our other case here, we'll just write it over here a bit. 2x is equal to n pi plus minus 1 to the power of n, 3 pi on 4. So that is our 2x. So we can divide through by 2. So x is equal to n pi on 2 plus minus 1 to the power of n. So our pi on 4 is going to divide it by 2, pi on 8. And same over here, x is equal to n pi on 2 plus minus 1 to the power of n, 3 pi on 8. So we take our fraction out the front. So 1 on 8. Here, to fraction on 2, so it's going to be here 4n pi plus minus 1 to the power of n pi. Again, over here, 1 on 8, 4n pi plus minus 1 to the power of n, 3 pi. Okay, so now looking at question 6, it's a little bit more complicated again here. So we have our double angle and we have here our cot. So what we're going to do is work through sort of step by step here. So we remember tan of 2x is equal to 2 tan of x on 1 minus tan squared x here. And we know our cot of x is 1 on tan x, so we can substitute both of these values in. So we have here 2 tan of x on 1 minus tan squared x is equal to 1 on tan x. And so we can cross multiply over here. So we're going to end up with 2 tan squared x is equal to 1 minus tan squared x here. So we move our tans onto the same side here. 2 tan squared x plus tan squared x is equal to 1. So 3 tan squared x is equal to 1 here, and then so we have tan squared of x is equal to 1 on 3. So our tan of x is equal to square root of this, becomes 1 on root 3 here. So we go back here, we're wanting 1 on root 3 for our tan here, and that's going to be pi on 6. So we're looking here, we know we've got pi on 6 here. And so what we're going to be putting this into our formula here, our x is equal to n pi plus our alpha here, and we know because this is plus or minus pi on 3, because we've square rooted here, it's going to be x is equal to n pi plus or minus pi on 6 here. Okay, so now looking at question 7. For the first part, we want to prove part of our formula here. So we want to prove that 1 plus tan x tan 2x is equal to sec of 2x. So if we look at our left-hand side here, 1 plus tan of x tan of 2x here. So here we're going to put our values for our tan of 2x in. 1 plus tan of x, and remembering this is a multiplication here. So here tan of 2x is equal to 2 tan x on 1 minus tan squared x here. So here it becomes 1 plus 2 tan squared x, we multiply our tan here, 1 minus tan squared x. And so we can change here our 1 to be here 1 minus tan squared x over 1 minus tan squared x here, plus 2 tan squared x on 1 minus tan squared x here. So from here, we work through here, we've got 1 here minus tan squared x plus 2 tan squared x gives us plus tan squared x here over 1 minus tan squared x here. And 1 minus tan squared x is equal to sec squared x. And we can change our 1 here, so 1, and we've got tan squared x here is equal to sine squared x divided by cosine squared x here. So if we follow across, we keep on going here, sec squared x is here 1 on cosine squared x here. And so we're dividing, we're going to actually multiply here and flip over. We're going to end up with cosine squared x on cosine squared x minus sine squared x here. So we work through here, we're going to cancel here these ones, we're going to get 1 on cosine squared x minus sine squared x here, which is equal to cosine of 2x, and 1 of cosine 2x is equal to sec of 2x here is equal to the right hand side. So we've proven our equation here. And now for 2, we want to find the general solutions for the equation here. So we work through with this one here. We've got here 1 plus tan of x, tan of 2x here is equal to 2 cosine of x of 2x minus 1 here. So we can go through to different steps in our equation here, and we're thinking, well, we've got cosine here and cosine 2x here on our way through our actual working here. So we'll go straight to this point here. So we're saying here our 1 on tan x tan 2x can become 1 on cosine of 2x here is equal to 2 cosine of 2x minus 1 here. So we multiply across, 1 is equal to 2 cosine squared 2x minus cosine of 2x here. Put it all on one side, we're going to have 2 cosine squared 2x minus cosine of 2x minus 1 is equal to 0. We can, this will become 2 cosine squared 2x plus 1 multiplied by cosine squared 2x minus 1 equals 0 here. So from this we get here our cosine 2x is equal to minus a half, or cosine of 2x is equal to 1. So here, substituting through, 2x is equal to 2 pi n plus or minus 2 pi on 3, and here 2x is equal to 2n pi plus or minus 0. So here, dividing through by our 2, we get x is equal to pi n plus or minus pi on 3, and here dividing by 2, we get pi n plus or minus 0, it stays as pi n there.